To use a blockchain, you need three connected ideas: an account that represents you, a wallet that controls your keys, and a seed phrase that restores access. Together, they make ownership, signing, and wallet-based login possible. We've already built the foundation: shared ledgers, web access, and cryptographic identity. Now we'll connect those ideas to accounts and wallets, where users control identities and approve blockchain actions. A blockchain account is your identity on a blockchain. It has an address similar to a public account number, and it can hold crypto, tokens, or NFTs. Access does not come from a password. It comes from cryptographic keys. Whoever controls the private key can use the account to send transactions and interact with apps. There are two main account models. An EOA works like a normal user account. A private key controls it, and a wallet can sign and send transactions directly. A smart contract account is different. It is controlled by code already deployed on-chain. It usually does not act on its own. It responds when a transaction calls it, following its programmed rules. That difference powers tokens, dApps, and automated blockchain logic. Under the surface, blockchain accounts rely on a key pair. The private key is the secret proof of control, so anyone who has it can authorize transactions. From that private key, the system can produce a public key, which others use to verify signatures without learning the secret. An address is a shorter shareable identifier derived from the public key. Wallets hide most of this complexity, so users can receive assets and sign more safely. An address identifies the account, but the blockchain also tracks what happens to it over time: its balance, nonce, and transaction history. The nonce is especially important because it counts transactions, preventing an old signed transaction from simply being reused. Your wallet reads and presents this information, but it is not the source of truth. The source of truth is the blockchain's shared state. A blockchain wallet is less like a pocket for coins and more like a key manager. Your assets are recorded on the blockchain itself. The wallet protects the private keys that prove you can control those assets. It also organizes accounts and addresses, reads the network to show balances, and helps you review signing requests. When you approve a transaction, the wallet signs with your key. When you reject it, nothing is authorized. Wallet types are mainly about trade-offs. Browser wallets are easiest for connecting to dApps, but they depend heavily on browser and website security. Mobile wallets are convenient for daily use, QR codes, and biometric unlock, but your phone becomes the key environment. Hardware wallets add friction, but they isolate private keys offline, making them better for larger or long-term holdings. The right choice depends on how often you transact and how much risk you need to reduce. When a dApp or wallet creates a transaction, it packages the key details: who receives funds, how much moves, and what fee will be paid. The wallet then pauses for user approval because signing is consent. If approved, the private key creates a cryptographic signature locally. The key never leaves the wallet. Only the signed transaction is sent to the blockchain network, where validators check it and include it in a block. Your wallet is the last checkpoint before an action becomes real on-chain. It should translate technical requests into human questions. Who am I sending to? How much? On which network? What fee? And what permissions am I granting? This is especially important with smart contracts because approve may allow future token spending, sometimes unlimited. Warnings help, but they are not guarantees. Pause before signing. Verify the site, read the prompt, and reject anything you cannot explain. Hardware wallets reduce risk by changing where signing happens. Your computer or phone can prepare a transaction, but the private key stays sealed inside the device. The wallet shows the transaction details, and you physically confirm before it produces a signed transaction. That gives malware on the connected machine far less to steal. For large balances or long-term holdings, this is a major upgrade, but the recovery seed still needs careful offline backup. A seed phrase is the root backup for an HD wallet. The wallet turns those 12 or 24 words into a master key, and that master key deterministically creates accounts and addresses. That is why one phrase can restore everything after a phone or laptop is lost. It is also why the phrase is extremely sensitive. If someone else gets it, they can recreate the same wallet structure and control the funds. Treat your seed phrase like the master key to your wallet. Write it down offline, ideally on paper stored securely or on a metal backup that can survive damage. Never keep it in screenshots, cloud notes, email, or chat apps. Never type it into a website or share it with support. To reduce single point failure, keep multiple secure physical backups in separate trusted locations. A wallet can also work as an identity tool. Instead of sending a password, an app sends a one-time challenge. The wallet signs that message with the private key, while the key stays inside the wallet. The app verifies the signature against the wallet address. If it matches, the address becomes the user's identifier, and a normal session can begin. This is the core of sign-in with wallet. Great work! You've connected accounts, wallets, keys, and seed phrases. Next, we'll turn that foundation into passwordless login and hands-on message signing.